Hi folks, a lot of people out there, probably yourself included, if you're homeowners, you deal with potentially what you call water pressure problems. And people don't understand that it's probably actually a water volume problem. It's not a pressure problem. And I'm going to demonstrate that for you in very simple terms. I'm not a scientist. I'm not going to get in any kind of technical jargon that you might not understand, and I probably wouldn't understand. So we have pressure gauges on two different lines here. One's on an 1.5-inch line. It's showing about 30-35 pounds of pressure. And this is on a 3/4 line. You know, there might be a small kink in one of the lines. It should be identical. This is showing 40 pounds of pressure, but they're being fed by the same exact source. So the pressure is the same, but the volume is vastly different. So I'm going to give you a quick example, probably the only technicalese I'm going to get into. If you have a 1-inch water service line in your home, it's measured by how many gallons per minute it can provide, which is 8 gallons per minute, which is barely enough for a one-family home, according to New York City sizing tables. An 1.25-inch line, which is only one size larger, 1.25 inch, 1 inch, maybe cost $150 difference if you completely change your water line, gives you 75% more water, gives you 14 gallons per minute for about $150. Now I'm going to get in, that might be the last technical thing I'm going to show you. So 40 pounds of pressure, okay. Now, because it's interesting, because this hose is small, it still has resistance to the water flowing through. It still registers about 15 pounds of water. There's an interesting point. When you restrict the flow of water, you increase the pressure. And you know that. If you put your finger over the opening of your garden hose, well, that's more pressure, but it's less water. And that's the same principle for when you're taking a shower. You have a shower head. It makes the water have more pressure. Same thing with your sink. Same thing, like I said, with the garden hose. So we're going to shut this off. Now what you're going to see, which should be interesting, this is an 1.5-inch line, pretty much identical water pressure. When I turn this on, you remember how this was spraying out? This has no restriction on it. That's all you're going to get out of it. Because the flow of water is not being restricted, it's less pressure unless I restrict the flow. Then I get more pressure. You'll also notice that the gauge went down to 0. Why did it go down to 0? Because there's no restriction on the flow of water. The gauge drops to 0. 3/4-inch hose, it drops to about 15 because the garden hose is still restricting the flow. So that's the beginnings of the difference between pressure and volume. If you have a 3/4-inch line, you're not going to service your home, even though it looks like more pressure. An 1.5-inch line, you could have a 3-family home. So what we're going to do is, you think same pressure, it should fill up a water bottle in the identical amount of time, except for the difference in gallons per minute that the 1.5-inch line will provide, the flow. So this is the live part of the demonstration, a little bit of an unscientific demonstration, but I think it'll show that a lot of people, a lot of folks out there, if pressure is the same, the amount of water is the same. This is the definitive test to just easily show you, not true. We'll give the 3/4-inch line a bit of a head start, and we'll see what it takes to fill the water bottle. 1.25-inch line. I'm going to get a little wet. I'm going to get real wet. But look at the difference. Look at the difference. Over double. Same water pressure, over double the amount of water. Okay, so from these simple demonstrations, you should clearly understand that the gallons per minute, the flow rate, that's what increases, improves your quality of life, that you have enough water for all your fixtures. Pressure is a separate and distinct issue. It's not usually the problem you're going to deal with. And this should really clearly be an example as to why that's true. Thank you for listening, and I hope that helped you out there.